Do you know what all these symbols in Excel formulas mean? They show up in Excel all the time, and most people either ignore them or use them without really knowing what they do, which is crazy because these symbols can completely change how your formulas work. In this video, I'll walk you through each symbol and show you clever ways to put them to work so you can start using them on purpose. First up, the asterisk, which is a wildcard character. You can use it to search text patterns. For example, here I have a list of products that all contain apple in the name. Some have it at the start, some have it at the end, and some have it as part of a single word name. We can use COUNTIF to search this list and count all instances of apple. Close parentheses, and we only get one match. That's because it's looking for an exact match, albeit not case sensitive. Let's say we want to count cells that contain apple at the end of the name. Again with COUNTIF, referencing this range, comma. This time we're going to place an asterisk before apple, close double quotes, close COUNTIF, and this tells Excel to count any names that end in apple, irrespective of how many characters come before it. And we can see it finds 6 matches. What if we want to count cells that contain apple anywhere in this text string? So again, COUNTIF, referencing this range, and this time we're going to place an asterisk before and after apple, meaning apple can be at the beginning, middle, or end of the text. And you can see all 8 cells match when we use the asterisk wildcard either side of the search term. But what if you want to be more specific about the number of characters either side of the search term? That's where the question mark comes in. The question mark matches exactly one character, no more, no less. For example, here I have a list of order IDs, and I want to count all the ones that follow the format AB12, followed by one unknown character, which would be AB12A, AB12B, or AB123. And we can do this with SUMIF. The range is my order IDs here. The criteria is going to be AB12, followed by a question mark for any single character. Close double quotes, comma, and then the range we're summing are the sales values. And we get 6,000, which are these cells here for AB12A, AB12B, and AB123. Notice it doesn't include AB12C5 because that's too long. If you want to match order IDs like that, let's copy this formula and we'll just modify it. You can place another question mark for another wildcard character, and this time it returns the sum for this cell because this is the only order ID that has 2 characters after AB12. So to recap, use the question mark when your pattern is fixed in length and you expect a variation in a specific number of positions, and use the asterisk when you expect any number of character variations. But what if you want to search for an actual question mark or asterisk in your data? That's where Tilde comes in. Let's say you have a list of comments, some are statements and some are questions. You want to count how many questions you have. Based on what you've learnt so far, you might place an asterisk either side of the question mark, which you can see here returns 3 because it's treating the question mark as any single character surrounded by any number of characters as denoted by the asterisks. So basically it counts all cells containing at least one character. If you want to search for an actual question mark, again we use COUNTIF, referencing the range here. This time the criteria is asterisk, and then we place a tilde before the question mark to make the question mark a literal character, followed by an asterisk, close double quotes, close COUNTIF, and you can see it finds one instance, which is this one here. In this file that you can download from the link in the video description, you'll find this handy reference table that gives you examples of when you might use the tilde to escape these special characters. Now let's talk about the curly braces. They might look like something typed in by accident, but in Excel they have a specific purpose, and that is to enclose arrays. Let me show you an example. Let's say you want to create a series of quarter start dates for 2025. We can use the date function, the year 2025. And then instead of entering a single month here, we can enter all 4 in an array, which we define with a curly brace. So I want January, April, July, and October. Close curly brace on my array of month values, and then I want 1 for the first day of each of those months. I press enter and the date formula returns each quarter start date in a spilled array. Now my dates are day, month, year, so this is October, July, April, and January. Alternatively, if you want a horizontal array, you simply change the separator between each month value. So instead of a semicolon, I'm going to put a comma, 4, 7, and 10, close my curly braces, comma, 1 for the day, close parentheses, and I get a horizontal array. So arrays separated with semicolons are vertical arrays, and horizontal arrays are separated with a comma. Now, a couple of notes. First, this build behavior works in Excel 2019 onward and Microsoft 365. In older versions, you need to select the entire output range first, then type in your formula, and when you enter it, you need to press Ctrl, Shift, and Enter all together. And if you look in the formula bar, you'll see Excel has added an additional set of curly braces around the outside of the formula, which tells me this is an array formula that's been entered with Ctrl, Shift, and Enter. I'm going to Ctrl Z to undo that because I have 365, so my array formulas spill. When you're summing a column of numbers in Excel, your first instinct might be to select a range large enough to allow for new data to be added without having to edit the formula. But depending on the function, referencing ranges bigger than you need can slow things down, especially in big spreadsheets. And if you forget to update the range as your data grows, your totals will be wrong. Enter the new trimref operator. So now all I need to do is reference as many cells as I need, and if I want to trim any empty trailing cells, I simply place a dot after the colon. This tells Excel to trim any empty cells from the bottom of the range before passing it to sum or any other function you use it in. Now in this example, both formulas return the same result, but the second one is future-proof because if I add more rows later, you can see it automatically includes it, whereas this one I'd have to edit. By the way, you can also add a dot before the colon, and that's going to trim any leading empty cells. And for even more control, we have a new trim range function, which builds on the same idea but gives you more options when trimming rows and columns together. So check out the deep dive lesson here, which also covers why you might use this new feature instead of tables. If you've made it this far, you're clearly not just using Excel, you're thinking about how to use it better. And if you're ready to move beyond the basics and start building spreadsheets that solve real problems, my Advanced Excel Expert course is a great next step. It's built for people who want to work faster and finally stop second guessing whether they're using the right approach. Inside the course, I'll show you how to solve real business problems and the exact structure I use in my own work. You'll get downloadable workbooks, walkthroughs, and exercises to help you actually apply what you learn, not just watch and forget. I'll leave the link in the video description and pin comment if you'd like to join. Spilled array formulas, like unique here, are one of the best new features in modern Excel, and when you reference Excel tables in formulas, any new data is automatically included. For example, if I add a new record in the next available row under the table, you can see unique has included it. But notice the count here hasn't updated because it doesn't include the cell for that new record. And that's where the hash sign comes in handy. So instead of referencing the fixed cell range, I can just reference the first cell in my spilled array, followed by the hash sign. Notice it automatically detects the spilled array, press enter, and now if I add a new record to my table, my spilled array has updated, and my count has automatically included it without me having to edit the formula. The hash symbol is a game changer, and there are some cool ways you can use it, which I cover in the deep dive video linked to here and in the video description. Next up is the $, which is one of the key foundations of formula writing and should be one of the first things you master. Let's say I want to count the employees by department, which I can do with COUNTIF. The range are the departments here, comma, and the criteria, well, I've got them listed in this column here. Press enter, and then if I copy it down, it looks like it's working, but let's F2 to edit the cell, and you can see, oops, my department reference has slipped down a row, and so on. It gets worse and worse as we go down. And we solve this by using the $ to tell Excel which part of the reference to lock in place. I want to lock the range, which I can do quickly with the F4 key to insert the $ for me. I want to keep the reference to the criteria relative, so I don't need to apply any $ there. Let's press enter and copy it down, and now we get the correct count. If I edit the cell, you can see the range is fixed on the departments, and the criteria automatically updates as the formula is copied down. So you can see using the dollar signs makes it quick to write the formula once and then copy it to reuse it elsewhere. And we can modify the placement of the dollar signs to enable copying a formula across and down. For example, here, let's use SUMIFs to populate this table. So I want to sum the salaries, and I want to always reference that range of cells. So F4 to apply the absolute referencing, comma, the criteria range, or the first one, let's go with the departments. And again, F4 to lock that in place. Next is the criteria. Well, that's in this cell. Now I want to copy this formula down and across. So I want to always reference column M. That is, I need to lock that in place. So I'm going to press F4 once, twice, 3 times, and you can see it toggles through the different absolute referencing, applying the dollar signs where I need, comma. Next is the year, and again F4 to lock that in place. This time I'm referencing this row of values, so I want to lock the year in place, so that's F4 twice. Close parentheses on my SUMIFs, and now I can copy that to the rest of the cells in the table. I've written the formula once, and having those absolute and relative references has enabled me to do that really quickly. One thing to note, if you're using a laptop, you may need to press or hold the function or FN key to enable the F4 key to work. Let's say you're working with data in an Excel table, as I have here. You can see on the Table Design tab, it's called Stock. That is, it's a table I created with the keyboard shortcut Control-T. Alternatively, you can create a table from the Insert tab and then Table. Now when you reference a column in an Excel table, you don't use cell ranges like G9 to G26 anymore. Instead, Excel uses the table name followed by the column name inside square brackets, and this is called a table structured reference. And notice I was able to reference the whole column by clicking in the header, and Excel inserted the table structured reference for me, including the square brackets. Now all I need to do is press enter, and there's my formula. Now another way you can reference the table structured references is to simply type in the table name. You can see it's come up in the IntelliSense, so I can tab to insert it, and then open square bracket, and I get the list of elements I can reference. So I can arrow down and choose the column that I want, tab to insert it, close the square bracket, close the parenthesis on sum, press enter, and my formula is done. So you can see referencing tables using the square brackets is super quick and easy, plus it makes your formulas easier to read. We just saw how Excel tables use square brackets to reference entire columns. But what if you're writing formulas inside the table and you want to refer just to the current row? That's where the @ symbol comes in. For example, I can calculate the stock value by referencing the price column times the stock. Notice Excel automatically puts the @ sign in for me and wraps it in square brackets. And it doesn't need to prefix it with the table name because the formula is inside the table. When I press enter, the formula is automatically copied down for me. And if you look in the formula bar, you can see the formula is the same on every row, yet the formula is returning a different result. And that's because the @ sign is telling Excel to reference the values on the current row of each column. Notice if I write this formula outside of the table, it prefixes it with the table name. And that's to avoid any ambiguity. Now the thing to understand here is the @ symbol only returns the value when it's in a row next to the column it's referencing. If I reference a row in the table above or below the current row, it will use the A1 reference style. And if I copy a formula that uses the @ signs above or below the table, I get an error. Now most of the time you don't need to type the @ symbol in yourself, Excel will do it for you, but it's important to understand how Excel treats formulas containing @ to avoid errors. Next up is the apostrophe, which tells Excel to treat the cell's contents as text, even if it looks like a number or a formula. For example, let's say you want to enter part numbers or codes that contain a hyphen. So my part number is 012571. I press enter and it thinks it's a date and converts it. Let's Control Z to undo. To avoid this, type an apostrophe first, then 012571, press enter, and now Excel understands this is text and it doesn't mess with it. Now you can't see the apostrophe on the face of the cell, but if you look in the formula bar, you can see it there. It's perfect for special characters, numbers with leading zeros, part numbers, or formulas that you don't want to calculate. Once you understand how Excel interprets symbols like these, writing formulas gets a lot easier. But if you want to go from just understanding formulas to actually standing out with them, that's where this next video comes in. It covers 10 powerful Excel functions that professionals rely on to solve real problems. Plus, there's a free cheat sheet to keep by your side. I'll see you there.